Welcome back to the Deep Dive. Today we're diving into something really critical in our AI-driven world. It's how we keep sensitive data secure within those amazing, powerful machine learning systems.
Yeah, generative AI, we all see it, right? It's transforming businesses, writing code, doing marketing stuff. It feels almost like magic sometimes.
It really does. But, and this is the big question, the one people maybe don't ask enough, what happens when these super smart models need to chew on your most sensitive information, your private data?
And that's exactly where the magic can turn into a real nightmare, a massive headache, or honestly, even a devastating data breach if you're not careful.
Right.
So this deep dive is all about that crucial meeting point between data security and machine learning. How do organizations handle the whole life cycle of an ML model? From the moment it gets raw data right through deployment, keeping personal stuff, proprietary info locked down tight, and crucially, without wrecking the model's performance.
That's the tightrope walk, isn't it? It's a huge challenge. So our mission today is pretty clear. Walk you through the key stages of that machine learning pipeline. We'll uncover the specific security problems, the hurdles that pop up at each step. But we're not just pointing out problems.
No, definitely not. We're going to show how specialized solutions, how they bring privacy protection to training, to inference, every point along the way.
Exactly. The goal is to give you kind of shortcut, a way to quickly grasp this complex, super important world of data security in AI. So let's unpack it.
Okay, let's start with why. Why is data security in ML just so incredibly important right now? First off, it's the sheer amount of data, just vast quantities. Machine learning pipelines, think of them like massive data rivers. They process enormous amounts of information, and a lot of that is often really sensitive stuff.
What kind of sensitive stuff are we talking about?
Well, you've got PII, personally identifiable information. That's the obvious stuff. Name, address, social security number, anything that points directly to you. Then there's PHI, protected health information, your medical records, treatment history, super sensitive. And NPI, non-public information. Think financial forecasts, company trade secrets, internal strategies, stuff you definitely don't want getting out.
And layered on top of that data deluge is the speed, the explosion of AI adoption. It's everywhere.
It really is. There was a McKinsey report looking ahead to 2025 that found over 70% of employees think Gen AI will change like 30% or more of their job within just 2 years.
Wow, 70%.
Yeah. And get this, employees are apparently 3 times more likely to already be using these tools than their bosses even realize.
So it's happening under the radar almost.
Kind of. And that rapid, sometimes stealthy adoption, it just makes robust data security absolutely non-negotiable. It's not a nice to have anymore.
Not at all. And then there are the rules, the regulations.
Oh, yeah. You've got GDPR in Europe, CCPA out in California, IPA for health data here in the US. These aren't just suggestions, they have real teeth. Big legal risks, massive financial penalties if you get it wrong. So organizations are constantly trying to balance needing great training data with these really strict privacy rules. It's tough.
It's a real balancing act. And it's not only about compliance, is it? There are wider cyber risks, too.
Definitely. The global cybersecurity outlook for 2025, it paints a pretty concerning picture.
Yeah.
72% of organizations are seeing more cyber risks. And almost half, nearly 47%, their biggest worry is attackers getting smarter because they're using generative AI themselves.
So AI is both the tool we need to protect and potentially part of the threat.
Exactly. It just highlights why securing this data pipeline is so critical. It's like an arms race, and you need the best defenses.
Okay, so with all that context, the high stakes, let's actually walk through this machine learning pipeline. What is it, fundamentally?
Right. So an ML pipeline, think of it as a systematic workflow. It's the whole journey data takes from being just raw input all the way to becoming a working, deployed AI model. The key thing is it ensures the process is repeatable, you can scale it up, and you can maintain it over time. It brings structure to the whole ML project.
Got it. So not just random steps, but a defined process. And you mentioned stages.
Yep, there are generally 7 core stages people talk about, and each one brings its own specific security challenges. We start with data collection and storage. That's getting the raw data in.
Okay, stage 1.
Then it moves to data pre-processing and cleaning. Got to get that data refined, ready for use.
Makes sense. What's next?
After cleaning, you get into feature engineering and dataset creation. This is where you transform the clean data into the specific things the model will actually learn from.
The features.
Which leads right into model development and training. This is kind of the heart of it, where the algorithms learn from those carefully prepared datasets.
Training the brain, so to speak.
Pretty much. Then, once it's trained, it's model evaluation and validation. You have to rigorously test how well it performs.
Check its homework.
Exactly. If it passes, it goes to model deployment and monitoring. It goes live, starts doing its job, and you watch it carefully in the real world.
And it doesn't stop there.
Nope. Finally, there's the ongoing maintenance and updates stage, keeping the model effective, secure, retraining it as needed over its lifetime.
Okay, 7 stages. Let's dive deeper, stage by stage.
Yeah.
Challenges and, importantly, the solutions. Where do we start?
Let's start right at the beginning. Data collection and storage, the big challenge here. Managing getting huge amounts of data, often from all sorts of different places, while making sure you're compliant with all those rules we mentioned.
Yeah.
GDPR, CCPA, all that.
So you've got this flood of data coming in. How do you stop the sensitive stuff from just, slipping through the cracks?
Well, a key part of the solution involves automated sensitive data discovery tools. Think of them like digital bloodhounds. They constantly scan everywhere you store databases, cloud buckets, file shares using smart pattern matching, understanding context to find sensitive info wherever it might be hiding.
So they sniff it out automatically.
Right. Then you layer on top of that things like real-time monitoring, access controls based on roles who should see what, often using dynamic data masking.
Dynamic masking, what's that?
That means the data gets masked on the fly as someone accesses it. So the original data stays untouched, but the user only sees a masked version based on their permissions.
Clever.
Yeah. Plus, comprehensive audit trails logging who accessed what, when, and even things like a database firewall, which can just block unauthorized users from even connecting to sensitive production databases, like a bouncer at the club door.
Okay, so robust controls at the entry point. What about the next stage? Data pre-processing and cleaning.
Right. Here, the challenge shifts a bit. You need to clean the data, make it usable for the model that's beta utility, but you still need to protect sensitive bits. And data comes in all shapes and sizes, right? Structured tables, semi-structured logs, unstructured text like emails or documents.
How do you protect sensitive info but keep the data useful across all those formats?
This is where static data masking often comes in, particularly using something called format preserving encryption, or FPE.
Format preserving. So it keeps the original format.
Exactly. You create copies of your production data, but they're de-identified. Sensitive info is replaced. But, and this is key, it looks like the original data. A 16-digit credit card number still looks like a 16-digit number, just not the real one. A name looks like a name.
So the model can still work with it easily.
Precisely. And crucially, these masking techniques preserve the statistical properties, the relationships within the data. That's vital for training an accurate model. It learns the patterns, but never sees the actual sensitive details.
And you automate this.
Ideally, yes. Automated protection workflows apply these rules consistently across the board, so you're not trying to manually mask every single piece of data. That would be impossible.
Okay, makes sense. Next up was feature engineering and dataset creation. What's the challenge there?
Here, you're building the specific datasets the model will train on. The trick is creating datasets that are representative of the real world, maintain data quality, and preserve those important relationships between different features. This gets particularly tricky if you need to share data, maybe across borders where privacy laws differ.
Right. How do you solve that? Taking smaller pieces of data?
That's part of it. Intelligent subsetting, taking a smaller but still statistically representative slice of the production data. But you also have to be careful to maintain things like geographic distributions or patterns over time, and you need to maintain referential integrity. That means if customer ID 123 is linked to purchase ABC in the real data, the masked version of 123 should still be linked to the masked version of ABC. The relationships need to hold. Privacy-preserving record linkage techniques can help here too.
So you keep the structure and relationships intact, even with masked data.
Got it. Now the big one, model development and training.
Yeah, the core of it. The challenge here is enabling data scientists to actually build and train effective models while still protecting that sensitive data and the company's intellectual property, especially when you have teams collaborating.
So how do developers work without seeing the real sensitive stuff?
This is where you set up secure development environments. They use that anonymized, masked data we created earlier, maybe using that format-preserving encryption again. This lets data scientists work with data that feels realistic. It has the right shape and statistical properties, but it's completely protected. No real sensitive info is exposed.
And does that protection cover just the data they train on?
Good question. No, it should also extend to the model itself, the artifacts that get created, like the model weights. Sometimes analyzing the model weights could potentially reveal patterns from the original sensitive data, so you need to secure those too.
Can you give us an example of this in action? Sure. Let's take a bank. Say they're building an AI model to assess creditworthiness for car loans. To train this model well, it needs to learn from past applications. It needs data like William Gillespie's application, his name, address, social security number, maybe past loan outcomes. That stuff is crucial for the AI to learn how to verify identity and predict risk accurately.
But that's all highly sensitive PII, especially in finance with strict regulations.
Exactly. So this is where a platform like Mage data comes in. They allowed the bank to train the AI on data that looks and feels like real production data, but without exposing any of the actual PII or sensitive financial details.
Using that masking we talked about.
Yes, applying context-preserving masking and tokenization. It strips out the sensitive elements but leaves data that's still rich and high quality for the AI. The amazing result is the AI gets trained accurately. It learns the patterns it needs to, but without ever seeing or using the actual sensitive customer data. It's a real win-win. High performance, rock-solid privacy.
That makes sense. Okay, so the model is trained. What about model evaluation and validation?
Right, testing time. The challenge here is needing consistent test environments. You need to accurately measure how well the model performs, but again, without compromising the sensitive data protection you've put in place.
So more masking?
Consistent masking, yes. You need to ensure the data masking rules applied in testing are the same as in development and training. This maintains data utility so you get a true picture of performance, but everything stays protected. You also need things like comprehensive access monitoring for the test environments and secure validation processes, so those test data sets themselves are locked down. You're basically creating a safe sandbox for rigorous testing.
Okay, testing done. Model passes. Now it goes live. Model deployment and monitoring. What are the risks here?
Once it's in production, the game changes slightly. You're dealing with live data now. During inference, that's when the model makes real-time predictions or decisions. So the challenges are protecting that live data, ensuring the model keeps performing well, and securing the endpoints, the connections to the model.
And the solutions there.
You're looking at things like database-level intrusion protection, watching for suspicious activity. Continuous access monitoring is key, integrating with your existing security tools like SIEM systems, and also automated workflows for data retirement, making sure sensitive data used in production doesn't just sit around forever once it's no longer needed. Managing that whole life cycle.
Right. Data shouldn't live longer than necessary. Okay, final stage. Maintenance and updates.
Yeah, the long haul. The challenge here is consistency. As you update the model, retrain it with new data, you need to ensure those security policies are applied consistently every single time, and you need to manage the data lifecycle as the model evolves.
How do you ensure that consistency over time?
Automation is key again. Integrating automated protection workflows directly into your DevOps or MLOps pipelines, the processes for developing and deploying software and models. This ensures security is baked in, continuously applied with every update or retraining cycle. Plus, maintaining comprehensive audit capabilities gives you that ongoing visibility and control, proving you're managing sensitive data properly throughout the system's life.
That covers the traditional pipeline really well. Yeah. But you mentioned generative AI earlier. That seems like a whole new ballgame, especially how we interact with it.
Absolutely. It's a rapidly evolving area, and it brings a very specific and urgent security challenge, the prompt problem.
A prompt problem.
Yeah. When people use powerful, often cloud-hosted Gen AI tools, think ChatGPT, Copilot, tools like that, they interact with them by typing in prompts. And it's incredibly easy for sensitive data, PII, financial numbers, confidential plans, source code to end up in those prompts.
And once you hit send.
Exactly. Once you submit that prompt, that sensitive information can leave your organization's control. It might get stored by the Gen AI provider, logged somewhere, maybe even used to train their big external models.
Yikes.
Yeah. And just telling employees, hey, don't put sensitive stuff in prompts, relying on policy alone, it's just not enough. It's too easy to make a mistake or forget. Data leakage is a huge risk here.
So you need something more technical, something proactive.
Precisely. And this is where new solutions are emerging, like Mage Data's Gen AI firewall. It's designed specifically for this problem. It adds real-time monitoring right at the input, right where the user types the prompt. It automatically detects sensitive information before the prompt ever gets sent to the Gen AI model.
It stops it before it leaves.
Yes. It can detect and block sensitive prompts entirely, or, even better, protect the data within the prompt using what's called a zero-trust prompt architecture.
Zero-trust prompt architecture, how does that work?
It's a multi-step process happening in real time. First, it identifies and classifies any sensitive elements in the prompt as you type names, IDs, financial terms, whatever you've defined as sensitive.
Okay, finds the risky bits.
Then it masks those bits. It replaces them using techniques like masking, tokenization, or even generating realistic-looking synthetic substitutes. This happens before the prompt ever reaches the cloud GenAI service. So the GenAI model itself only ever sees anonymized content. Nothing sensitive actually leaves your secure environment.
But if the Gen AI gets an anonymized prompt, won't the answer be kind of useless or generic?
Ah, that's the clever part. The third step is rehydration. When the GenAI sends back its response, which is based on the anonymized prompt, the Mage data solution securely reinserts the original correct contextual terms back into the response, but only for the end user to see.
Whoa! So the AI never sees the real data going out or coming back, but the user gets a perfectly useful, relevant answer with the right context restored.
Exactly. Imagine an employee using a public GenAI to help write a customer email. The firewall masks the customer's name and account details before sending the prompt. The GenAI helps rewrite the email using placeholders. Then, the firewall takes the AI's response, puts the real customer name and account number back in, and the employee sees the finished, ready-to-send email. The GenAI never saw the sensitive data, but the employee gets the full benefit.
That is genuinely clever.
Uh,
It turns privacy from a barrier into, well, you called it a Gen AI edge.
it really enables safe usage of these incredibly powerful tools.
Okay, so looking across this whole landscape, the traditional pipeline stages, the new Gen AI challenges, it's clear you need a really joined-up, comprehensive approach to data security.
Absolutely. You can't just tackle one piece. And companies like Mage Data, they really embody that integrated approach. Their platform isn't just one tool, it's a suite. They offer solutions for sensitive data discovery, static data masking, that dynamic data masking we talked about, and continuous security monitoring, all designed to work together.
And you mentioned they focus on balancing compliance and utility.
Yes, that's critical. They have pre-configured masking policies ready to go for regulations like GDPR, CCPA, PCI DSS for payment cards, HIPAA. That helps organizations meet compliance needs quickly. But just as importantly, their masking techniques are designed to preserve those statistical patterns, geographic distributions, and the referential integrity we discussed. That's vital. Your masked data still needs to be useful for accurate analytics and AI model training.
And they seem to be recognized for this.
They are. They've got strong recognition from industry analysts like Forrester and Coppinger-Cole in areas like data masking and security platforms. And winning the Gartner Peer Insights Customer's Choice Award 3 years straight, that speaks volumes about how their actual customers feel.
That kind of validation is important.
Definitely. And their innovation shows, too. They hold patents for things like integrated data security systems and classification-centric discovery. Plus, their client list is impressive: Swiss banks, Fortune 500s, major universities across more than 20 countries.
They back this up with certifications.
Right. Things like ISO 27001 for information security management, and they undergo rigorous third-party security testing, pen testing, VAPT, following standards like OWASP and SANS 25. It shows a commitment to building trustworthy, secure solutions.
Okay, so let's try and wrap this up. To recap our deep dive today, securing sensitive data across that entire machine learning pipeline, it really demands a comprehensive strategy, doesn't it? One that carefully balances robust protection with maintaining data utility.
Absolutely. It's not an either situation. You don't have to choose between innovating with AI and keeping data secure. The goal is to enable both at the same time.
And it sounds like understanding the unique challenges at each specific stage, from collection right through to maintenance, and then leveraging these advanced integrated solutions, that's the path forward.
Exactly. That's how organizations can build secure ML pipelines. Pipelines that not only protect sensitive information and meet compliance demands, but also unlock real business value and foster innovation without cutting corners on security.
Which brings us to a final provocative thought for you, our listeners, to chew on. As these AI models become even more common, more powerful, and maybe even start generating their own data, think synthetic data, deepfakes, entirely new insights, what completely new layers of privacy challenges might emerge then? How are we going to ensure trust and accountability in a world where data is constantly flowing, being changed, used, and maybe even created by machines? What does that future mean for our fundamental understanding of privacy itself? Definitely a lot to think about there. That's all the time we have for this deep dive. Thanks so much for joining us today.
Thanks for having me.
And we'll catch you next time for another deep dive into the world of fascinating insights.